Hi everyone, this is Sugantha Priya, Assistant Professor, Department of Computer Science, Dr.S.N.S. Rajalakshmi College of Arts and Science. This presentation is about scheduling in operating systems. Scheduling in a multi-programming system, frequently multiple processes competes for the CPU at the same time. When two or more processes are simultaneously in the ready state, a choice has to be made which processes to run next. This part of the OS is called as a scheduler and the algorithm is called as a scheduling algorithm. There are two types of scheduling, namely long-term scheduling and short-term scheduling. For example, if you consider in batch systems, there will be often one or more processes submitted than the number of processes that can be executed immediately. So incoming processes are spooled to a disk. The long-term scheduler selects process from this process pool and loads selected processes into the memory for execution. The short-term scheduler selects a process to get the processor from one among the processor which are in the memory. There are several scheduling criteria: CPU utilization, throughput, turnaround time, waiting time, and response time. In CPU utilization, we have to keep the CPU as busy as possible. It may range from 0 to 100%. Throughput means it is a measure of work in terms of number of processes completed per unit time. Turnaround time means it is a sum of time periods spent in waiting to get into the memory, waiting in the ready queue, execution of the CPU, and doing input output operations. Turnaround time is calculated as time of the completion job minus time of submission job. Waiting time is a sum of periods waiting in the ready queue. Response time is the amount of time spent it takes to start responding, not the time taken to output that particular response. There are two types of scheduling algorithms can be divided into two categories with respect how they deal with the clock interrupts. One is preemptive scheduling and non-preemptive scheduling. A preemptive scheduling picks a process and let it run for a maximum amount of fixed time, whereas in the non-preemptive scheduling, the algorithm picks a process to run, just let it run until it blocks either an on IO or waiting for another process or until it voluntarily releases the CPU. Next is scheduling in batch systems. These are the three algorithms that is used in the batch systems, namely FCFS, shortest job first, and shortest remaining time next. Shortest job first, this is known as shortest job first or SJF. Jobs are executed on first come first serve basis. So best approach is to minimize the waiting time. Easy to understand and implement. It is an implementation based on the FIFO queue. It is impossible to implement in the interactive systems where required CPU is not known. Next is shortest remaining time. Next is a preemptive version of the SJN algorithm. Each processor is allocated to the job closest to completion, but it can be preempted by a newer ready job with shorter time to completion. It is impossible to implement in interactive systems where required CPU time is not known. Next is it is not often used in batch environment where shortest jobs need to give preference. Next is the scheduling in interactive systems. Round robin scheduling. Round robin is a preemptive process scheduling algorithm. Each process is provided a fixed time to execute called quantum. Once a process is executed for a given period, the process is preempted, other process executes for the given time period. Context switching is used to save the states of the preempted process in the scheduling. This is an example for a round robin scheduling where we have a different process like P0, P1, P2, P3, etc. And the time quantum for each process is allotted is equal to 3. So the total average waiting time is 8.5 in the round robin scheduling. Next is the priority scheduling. Priority scheduling is one of the non-preemptive algorithm and it is one of the most common scheduling algorithm that is used in batch systems. Each process is assigned a priority. Based on the priority, that is the process with the highest priority will be executed first and so on. And the process with the same priority are executed on the first come first serve basis. And the priority can be decided based on the memory requirements, time requirements, and any other resource requirements. This is an example of priority scheduling. We have different processes like P0, P1, P2 and P3. So each process is assigned a priority. Say based on the priority, the processes are executed, and the average waiting time for the P0, P1, P2 and P3 it is 6.5. Next is a multi-level queue scheduling algorithm. A multi-level queue scheduling algorithm partitions a ready queue into several separate queues. The processes are permanently assigned to the one of the queue. It is generally based on the some property of the process, such as memory size, process priority or process type. Each queue has its own scheduling algorithm. Next is the shortest process next, SPN algorithm. The selection function, that is the process with the shortest accepted CPU burst time, is executed first. So the decision mode is non-preemptive. It is an IO bound process which will be picked first. Next we need to estimate the required processing time of the CPU burst time for each process. Next is a guaranteed scheduling. Make real promises to the user about the performance. If there are n users logged into the system while you are working, you will receive about 1 by n of the CPU power. Similarly, on a single user system with n processes running, all things being equal, each one should get 1 by n of the CPU cycles. To make good on this promise, the system must keep track of how much CPU each process had since its creation. CPU time entered is equal to time since creation. So, divided by n number of process. Thank you.